I've decided I need to make myself a desk lamp for close-up work. I have all the parts I need from previous projects, so I'll make it out of things I have on hand. And I'll concentrate on functionality. And if the function is great and I use it all the time, I'll go back and make it pretty later. My starting point was to build the circuit on a breadboard. I have a bag of LEDs that are perfect for the task. I get these little guys by the bagful. They're 5mm 3000 Kelvin temperature bulbs. They're white bulbs. And they can be gotten most anywhere in bulk for pretty cheap. And I also had on hand a transformer. I pulled out a 9-volt transformer, at least that's what it said. It says 9-volt, 150 milliamp, because I needed just a little lightweight thing to power these LEDs. They don't require much power at all. So I have the power leads on this breadboard over here, and those are 3 of these bulbs in series connected through a 68 ohm resistor, because I need some resistance in this circuit, otherwise it would just be an open short, nothing but diodes and a power source. So 68 is the amount I like to choose for most of my lamp projects. I'm going to plug in the AC-DC converter here to power the light bulbs up. And the bulbs are brighter than I anticipated. So I checked the voltage on these 3 in series. Now if this was a 9-volt transformer, there should be no more than, since they're in series, divide the voltage by the number of LEDs, and that would be 3 volts per LED, but I'm not putting 9 volts into it. I'm measuring closer to 12 volts coming out of this power supply. So I'm not sure if I'm just underdriving it or if it actually is 12 and it was labeled as a 9. So I cannot go down to 2 bulbs. That would be too much. I'm sticking with 3 in series. So and the power consumption. Let's look at that too, of course. I need to know how much energy we're consuming. Just 25 milliamps for this. So what I did was I continued with 3 in a series, and I just kept adding more bulbs in parallel until I hit 6 sets of 3 bulbs in series. So that's a series parallel of 18 bulbs in total. And I'm going to turn you off while I change the power supply to this other breadboard. We're going to see all 18 bulbs in action. And we're back with the power supply on 18 LEDs. I kept adding bulbs in parallel, and that would consume more amperage. And the voltage with all that going is still at 11.3, 11.2, 11.3, which is still quite high. So that thing may be mismarked. And the amperage is only 50 milliamps. So I like that. Multiply those together and you got about 0.6 watts with a lot of brightness that I can spread out. So I'm going to make a lamp out of that circuit, and I don't think I have to worry about heat because that's 0.6 watts. I can put that on plastic without worrying about anything melting. The next step now is sketching up a schematic diagram to print. So with my circuit breadboarded, I know exactly how many components I need. So I used a piece of cardboard to judge about how big I want my lamp head to be, and I drew all the LEDs and resistors directly onto the piece of cardboard. Then what I did was I used my flatbed scanner and I scanned my handmade design into a graphics vector program, and I just traced right over the top of it, and then I started moving components around. And then this completed schematic design I printed out on a piece of paper, so now I can transfer that circuit to the material of my choice. For the head of my lamp, I decided to use plastic corrugated material. It's used as yard signs, and after an election or use, people will take these plastic corrugated signs and just throw them away. So you can easily get them for free. I taped my schematic diagram right on top of the plastic and just cut it out for the head of my lamp. And here is the head of my lamp. I kept the schematic taped right to the plastic, and I mounted all my LEDs and other components straight to and through the plastic corrugated. I'll probably peel this paper off after I'm done with the project, but for right now it's nice to know where everything goes. And I'm using a 12 gauge house wire as an armature for the neck of the lamp. Also, I'm using that as the conductor for the electricity to get to the bulbs. And I've got the end bent up in a strange configuration because of the base of the lamp. The base of the lamp is another scrap piece of wood, a piece of scrap 2x4. I used a hand chisel, and I chiseled in this trench to fit the wire of the lamp. Let me bring that back over here. And it's going to fit together like a jigsaw puzzle here. Here we go. The base of the lamp is going to look like that. The wires are going to bend around for support. Right now these two are bent up because I need to put a quick disconnect on these wires for my AC/DC power supply. Once they're bent down, I'm going to fill this trench up with a 2-part clay epoxy to hold this all together. And I soldered that quick disconnect onto the end of my wires. And let's see if it works. Yeah, yes it does. In fact, let's turn off the lights. Works real nice. That'll be a very nice work lamp for me. I mixed up some epoxy sculpt, which is a 2-part epoxy, and I'm using it to secure the top of my lamp into the base. I rolled out a snake of epoxy and put it behind the wires, and then I stapled the wires in place to hold them very firmly. And I will be filling in the rest of this channel with epoxy sculpt, which is a very firm adhesive and structurally very hard. It's about the same consistency of wood. It can be worked with drills and sandpaper just like wood when it's dried. My workbench lamp from scrap material is finished. It's doing a great job illuminating my battery charger circuit. So I'll be able to get right in there and see nice and clear. Nice. Nice low profile, very lightweight, all scrap material. That bottom channel has been securely epoxied shut and sanded. Now all that remains is to use it and consider painting it to make it more pretty. Other than that, I got exactly what I want. It's doing a great job. See ya.